Hey, this is Peter from peterstestprep.com. Today we're going to learn about matrices, everything you need to know for the ACT exam about matrices. You're going to need this printout here. This is a worksheet. It's actually 4 pages full of information. We're going to go through this lesson and I strongly recommend that you print this out. The link for it can be found in the description at the bottom of the video. And you should follow along and you should do the exercises that are in here. As you do the video, that means you're going to pause regularly, do the problem or problems, and then we'll go over them as we teach you all of this material, because the best way to learn the material is to actually practice it and do it as you're learning it. And then you can hang on to this and study this, and you should know all of this down cold when you go in and take your ACT exam. So if you guys are ready, let's begin. This here is page 1 of the 4-page matrix worksheet and the lesson. And what we're going to do is I'm going to zoom in here and you guys can follow along. And again, as I said before, every time I suggest to pause the video, to stop it and do a problem that we're going to come across, you should do so. All right, so let's start from the very beginning, page 1, top left corner. What is a matrix? A matrix is a group of numbers organized into rows and columns. You may have as many or as few rows and columns as you wish. Now, a matrix is defined by its dimensions. A matrix dimensions are identified in terms of rows by columns. So here you have an example of a 2 by 4 matrix. You can see there's 2 rows and 4 columns. Let me have you take a look then at the next one immediately below it. Identify the dimensions of this matrix. So we're not going to pause here. I'll just give you a few seconds to identify what is this matrix's dimensions. And it is a 3 by 2. All right, the first easy thing to do is to be able to add or subtract matrices, or matrices. We're going to say matrices here. I'll get that focused. All right, matrices can be added or subtracted only if they have the same number of rows and columns. So here I'm going to add 2 matrices, each of which is a 2 by 3, 2 rows and 3 columns. Now, the important thing about matrices is that the numbers are not related to each other within a matrix, but rather by position across matrices or matrices. Now, how do I add these 2 matrices? Well, I take the top left number of the first matrix, I add it to the top left number of the second matrix, and that's going to give me my top left number in my answer matrix. I take the middle top number, the 5, of the first matrix, I'm going to add it to the middle top number of the second matrix, 6, together that's 11, and that becomes my top number in the middle in the answer matrix as well. All right, I'm going to have a pause here and have you just finish up this matrix for us. So go ahead and do that. All right, I'll finish this up then. 3 plus 1 is 4, 2 and minus 2 is 0, and we get a 2 there, and we get a 2 there, and this is what your final matrix should look like. Let's keep going. A number can be attached to the matrix to its left, and this is called a scalar. This number simply distributes to and multiplies each number inside the matrix to create a new matrix. So I have a 5 outside of this matrix, and what we do with this to simplify it is that 5 simply multiplies everybody inside that matrix there. So 5 times 2 is 10, and I keep going, and I filled in my matrix like so. Let's go to part C now on the top right. Here's our first important problem for you guys to do. 1C, simplify the matrix expression below. You have 3 times a matrix minus another matrix. It's a subtraction, not an addition. Go ahead and pause the video, please, and do question 2C. The answer matrix, like these 2 matrices here, will be a 3 by 2, 3 rows and 2 columns. To get the top left number, I do 3 times 2 is 6, minus 1 gives me 5, like so. Right? 3 times 2 minus 1 is 5. The top right number is a 4. 3 times 4 is 12, minus 0 gives me 12. And we just continue like that all the way through it. And here's what your result should look like. Now, another kind of question that we're going to get is what we're going to see now in questions 2D and E here. In both of these, we have a full matrix equation, and what we want you to do in each of these is to find the value of the variable. So find the value of x in the first one and the value of y in the second one. Please pause the video and go ahead and try to find x and y. Solve for x and y here. The secret to doing these problems is to recognize that in order to find x, only the numbers that are in the same position as the x in the other matrices matter. The other numbers do not. Or only the numbers that are in the same position as the y matter. All of the other numbers in these matrices don't matter. So in other words, to find x, I can set up an equation using only the numbers that are in that top position. 3 minus x equals 1, and we get x equals 2. In the second equation, don't forget about the scalar, the number on the outside. I can make an equation. 5y plus the 2 equals 22. And from that, we get y equals 4. None of the other numbers matter in these matrices. A real easy thing that we also now need to do is in number 3 on the bottom right here, how to find the determinant of a 2 by 2 matrix. Nobody really knows what a determinant is as far as I'm concerned. And we don't need to know what it is. We just need to know how to calculate it. And we can find the determinant of a 2 by 2 matrix very, very easily. So here, in order to find the determinant of a matrix that's 2 by 2, and we use the letters A, B, C, and D to represent generically the numbers that are going to be in those positions, what you do is you take A and D, the number that are in those positions, and multiply them. And then you're going to subtract the product of B and C. So box this in, put a star next to it. You must have this memorized. All right, go to part A below, find the determinant of this matrix. So I'm not going to ask you to pause. We'll just stay silent here for a few moments and let you calculate the determinant there. And hopefully you were able to quickly and easily find that. 4 times 3 is 12, minus 1 times 2 is 2, and the answer is just an easy 10. Right, let's go to page 2 now. And let's go to the second half of the lesson. Now, up until now, we've been doing basically the easy stuff, and everything that we've done so far, everybody going into this test should know at an absolute minimum. But here what we're going to do is take a look at more advanced stuff, and it's really not all that hard. The first question will be, how can you tell if you can multiply 2 matrices? So as it says here, sometimes you will be asked to actually multiply 2 matrices, and we'll learn how to do that shortly. However, you must first know when you can and when you cannot multiply matrices. So let's go to part A now. As a way to explore this, let us ask if we can multiply the 2 matrices A and B below. The first step is to write down the dimensions of each matrix in the space below the respective matrices. So matrix A, we can see, is a 2 by 3 matrix. Lift that up there. And matrix B is a 4 by 2 matrix. Now, can we multiply them? And the answer is no, cannot multiply them. Why not? Because the middle 2 numbers must match. So let's write down a rule for this. Again, you need to know this absolutely, positively down cold. And so let's write this down. So 2 matrices can be multiplied only with capital letters if the 2 middle numbers match. Right? That's your starting point. So we can see that A times B cannot be multiplied. Let's slide down to part B here and ask, well, if A times B doesn't work, can you do B times A? Well, using those same matrices that we had up there, we know that B is a 4 by 2, and A is a 2 by 3. Again, the first thing you always do is write the dimensions of A and B or whatever matrices you're working with underneath them. And now the middle numbers match. So yes, we can multiply B times A. Just sliding down a little bit more than on the bottom left here of page 2. So here we find that you can indeed multiply B times A. Order does matter when it comes to multiplying matrices. You always should write down the dimensions for the following reason. If we take a look now at the question C on the top right, it says, what will be the dimensions of the answer matrix to the product of B times A? Well, the answer is really easy, and this is actually one of the most fun things in all of math. The outer numbers tell you what the dimensions of the answer matrix will be. So if you take a look at your page down at the bottom, I'll go back there in a moment, our answer matrix will be a 4 by 3. Sliding back down to the bottom left of page 2. The middle numbers tell us that, well, yes, you can multiply B times A because you have a 2 in the middle. But the outer numbers give us the dimensions of the answer matrix. The answer is going to be a 4 by 3. This is extremely useful anytime there's a question that asks you about multiplying matrices. So we have this question part D. I'm going to zoom out just a touch here because it's a little space taken up with this. So part D, which of the answers below, it's a multiple choice question, which of the answers below represents the answer matrix to the following product? So why don't you pause the video and consider question 4D. The starting point should be to first determine what the dimensions are going to be of your answer matrix. So the first matrix is a 4 by 2. The second matrix is a 2 by 1, which means that our answer matrix is going to have what dimensions? 4 by 1. Those outer numbers tell us what the answer will be. The fact that the inner numbers are 2 and 2, and they match each other tells us that yes, you can multiply them. Well, that's easy. We don't have to do any more work because if you look through the answers, it is only answer D which gives us a 4 by 1 matrix. None of the other answers match, and we don't have to do any more work than that. All right, it's time for your break. Take a look at the screen and enjoy 3 seconds of our dog, Holly. All right, back to work, guys. We're on to page 3 now, and we're going to now learn how to multiply matrices. So I'm going to zoom in, and we're going to go to the top left section here. I'm going to teach you how to multiply matrices. It's actually quite easy. The first step is to identify the dimensions of your answer matrix and then draw such a matrix in. So I have a very easy little multiplication here. It can't actually be any easier than this. And so what you'll see is the first matrix is a 1 by 2. The second one is a 2 by 1. The middle numbers match, so we can multiply them. The outer numbers tell us we're going to have a 1 by 1. So I'm just going to draw in a 1 by 1 matrix, and I put a little dash there to indicate where my number is going to go. All right, how do you multiply matrices? Step 2 says each row of the first matrix multiplies each column of the second matrix. How do we do that? I take the first number of the row of the first matrix, the first number, and I'm going to multiply that by the first number in the column, the top number in the column of the second matrix. 3 times 1 is 3. I take the second number in the row and I multiply that by the second number in the column, and that gives me 8. If there were additional numbers, I would do the same thing. And then I'm going to add all of those together, and the result in this case here is 11. And that's it. That's how you multiply two matrices. I'm going to have you pause the video and take a look at A and B, and I want you guys to do exactly the same thing. Multiply these two pairs of matrices, please. Looking at the first product, basically have given you the same thing here as what I did moments ago. You have a 1 by 2 multiplying a 2 by 1. So we're going to have a 1 by 1 answer. So just draw that in, put in one space. 2 times 3. The first number in the row multiplies the top number in the column. That gives us 6. The second number in the row times the second number in the column gives me another 6. That's all of them, and I add them together, and I get 12. And my answer matrix is just the number 12, one entry, a single entry, as my matrix. The next one, well, it just adds one more number. I have a 1 by 3 and a 3 by 1, and once again, we get a 1 by 1. So we draw it in. I put a space for each of them. Minus 1 times minus 1 is 1. 0 times 5 is 0. 4 times 2 is 8. I add those two together, and I just get 9. All right, section 6 now. Multiplying matrices when you have multiple rows and or columns. First, we're going to just take a quick look at what we have here. We have a 1 by 2 times a 2 by 2. Now this one here is going to give us a 1 by 2 as an answer. There's a trick to doing this, and when you're multiplying matrices, you should take your second matrix and raise it up so that it's above the ceiling of the first matrix, like so that they're kitty corner like this. Then in the place where the two matrices form a corner, you should draw in your answer matrix. Now we're going to have a 1 row by 2 column matrix. And so I draw in a space for each of my numbers that are going to go in there. Now, setting this up like this allows me to easily figure out where I put the answer every time I multiply a row by a column. So the first row, and there's only one row here, 3 by 2, it's going to first multiply the first column. And you can see how the numbers kind of come together right in that first spot there, right? So those go there, they match here where the first entry is in the answer matrix. So we multiply this row by that column. So 3 times 4 is 12, 2 times 0 is 0, and I put a 12 there. I multiply this row now by the next column. That answer is going to go in that tight spot there. 3 times 1 is 3, 2 times 3 is 6, and we get a 9 in there. All right, it's your turn now. I'm going to ask you to multiply the two matrices, find the product of the matrices that are multiplied both in part A on the bottom left, and then also do part B on the top right. Do those two. Go ahead and hit pause, please. The key to multiplying matrices is the setup. I'm going to rewrite my matrices like so, where they're kitty corner to each other. The second matrix is up high above the ceiling of the first matrix and to its right so that they are kitty corner. Now I have a 2 by 2 multiplying a 2 by 2, which will give me a 2 by 2. So that 2 by 2 fits perfectly and snugly into the spot below and to the right, these two matrices. Each row will multiply each column. The top left number is going to come from multiplying the top row from the top column or by the top column. And you can see how they come together, right? They come together right in this position here. So 1 times 4 is 4, 2 times 0 is 0, so we get a 4 there. And then the first row by the second column, and I'm just going to go ahead, 1 times 1 is 1, 2 times 3 is 6, so I add those together and that gives me 7. Then the bottom row by the first column, that answer is going to fit in the bottom left here. We get a 12 there, and following the same procedure, we get a 0 here. 3 times 1 is 3, minus 1 times 3 is minus 3, and you add them together. Let's do the same thing real quickly in the top right. Again, let's just rewrite this, 2 and minus 2, 3 and 0, and 3, 4, 0, 0, minus 1, 2. And we have a 2 by 2 and a 2 by 3. The middle numbers match. I can multiply them. My answer is going to be a 2 by 3, and that's exactly what I expect, and it's exactly what I can fit in here. So I'm going to put a little line for each of my individual dot products is what we call this process that we're doing here. So the first row, top row by the first column, 2 times 3 is 6, minus 2 times 0 is 0, and we put a 6 there. Then the first row by the next column, and I'm just going to fill in these numbers here. All right, and that's how you multiply matrices. All right. Now, part 7, a practical application of multiplying matrices. A family consists of 2 senior citizens, 1 adult, and 5 children. They all go to see a movie. The cost of each movie ticket is $5 for each senior citizen, $12 for each adult, and $8 for each child. Part A says find the total cost of the family to go see the movie. So this is not a matrix question yet, so just pause here and go ahead and find the answer to that question. We have 2 senior citizens, and they pay $5 each. There's 1 adult who pays $12, and we have 5 children who pay $8 each, and when you add all of that up, we get $62. All right, there's a matrix question now. I'm going to zoom out a little bit so we can see this, but it's right there on your page 3. Which matrix product below would allow you to calculate the total cost for this family to see the movie? In other words, which one of these products follows the same process that we did for answering part A, which allows us to calculate the total cost of the family going to the movie. So hit pause and give this a whirl. There's some answers that don't make sense. Part A has us multiplying a 3 by 1 and a 3 by 1. I'm just going to zoom into the answers here. Well, that doesn't even make sense. You can't multiply them, so A is out. Now with B, you're multiplying a 3 by 1 and a 1 by 3, so you can multiply them, but the answer is going to be a 3 by 3. We're going to have 9 numbers in that matrix. Well, that doesn't help us calculate the amount of money that gives us a single answer that we're looking for, the amount of money that it costs the family to go to the movies. So that we have that problem with B, and D does the same thing. So now we're left with C and E. And with C and E, in each of them we have a 1 by 3 multiplying a 3 by 1, and that's going to give us a 1 by 1. Well, that's what we're looking for, is a 1 by 1. We're looking for a single number. Well, if you take a look at the numbers now for the first time that are within the matrices, the 2, 1, and 5 in the first matrix, well, that corresponds, or those correspond with the senior citizens. The 2 represents the senior citizens, the 1 represents the adults, and the 5 represents the children. If you multiply the first matrix in C by the second matrix, you'll see how magically this really works out. 2 senior citizens times $5 each is $10. Right, so that's our first number. The 1 adult multiplies by the 12, which is how much it costs each adult to go to the movie. So that's 12. And then the 5 children multiply the 8, which is the cost for each child. So there's 40, and there's our answer, 62. So the answer here would be a matrix of a single number, the number 62. E, if we just study this for a moment, and C is our answer, if we study E for a moment, you'll see that the 2 senior citizens multiplies the $8, and that doesn't make sense because the $8 does not apply to the senior citizens, so E is out as well. Let's go on to page 4 now and take a look at final topic here, topic number 8, creating an augmented matrix. Really easy. An augmented matrix is a way to represent a system of equations using matrices or matrices. The equation that we're working with, it has to be in the form of ax plus by equals c, or you can have more variables, but this has got to be in standard form where each of your terms with a variable in it is on the left, each of your monomials is on the left, and then the constant by itself is to the right of the equal sign. And to make an augmented matrix of the example equation here, 2x plus 3y equals 12, well, really easy. I just borrow the coefficients and the constant, and I just put them into the matrix in order. And normally you'll have a little line or dashed line to the left of the constant to separate it from the coefficients. Looking at the example of part A below now, we have a full system of equations. And we'll ask you now to create an augmented matrix, and you're just going to put the two rows above each other, one row for each equation. So you don't need to pause here. I'll just give you a few seconds to go ahead and do that. So from the top equation, we'll just borrow the coefficients, the 5 and the 2, and the constant, the 15, and write them out like so. And then the bottom equation, I put a 3. Now notice I'm going to put a minus 2 because this is 3a minus 2b, and then the constant 2. And again, there'll be a line to the left of the constant. So that is the wonderful world of matrices. If you know everything down cold that we've just gone over, then there pretty much should not be any question on matrices on the ACT that you will not be able to handle. Thank you for watching, and we'll hope that you enjoyed this and learned a lot, and keep an eye out for other videos.